Hello students, let us start variation of parameters method. But before starting the method, let us discuss what we have seen in higher order ordinary differential equations. So, suppose I have given the differential equation capital F of d into y is equal to Rx, right? Then what is our task? Our task is to find the general solution yx, which is the combination of two functions ycx as well as ypx, where ycx is known as the complementary solution and ypx is called particular integral. Right. Now to find ycx, what we do? We consider the given equation as f of d into y equal to 0, and for ypx, what we do? We write ypx is equal to 1 upon capital F of d into Rx. And for this particular Rx, we have seen three cases. Suppose Rx is exponential function, say e raised to some constant k into x, right? And I can write another constant here also, right? Another one is, suppose Rx is equal to k into either it is cos ax or you can say k into sin ax. And in the third case, suppose Rx is equal to any polynomial x raised to x, or I may write it as some constant k into x raised to x. And then in these three cases, we have two different methods, right? One is called shortcut method, and another one is called undetermined coefficient method. Undetermined coefficient method. In both of these methods, what is our purpose? Our purpose is only to find ypx. Now, in variation of parameters, again our purpose is to find ypx. That simply means that ycx remains same whether we are applying shortcut method or undetermined coefficient method or variation of parameters method, right? So what we are doing in the variation of parameter method, here I am considering the differential equation of order 2 only, right? So that is, what is the order of this differential equation? Order is 2. Only for this order, right now we are discussing variation of parameters. So suppose I have given the differential equation of order 2, right? So that means a0 d2y by dx square plus a1 dy by dx plus a2 into y is equal to r. And you can rewrite this equation as a0 d square y plus a1 dy plus a2y is equal to rx. And so if I take y common, then a0 d square plus a1d plus a2 into y is equal to r. So this is the given differential equation. For this equation, we need to find the general solution. So first I find what is ycx, right? So for ycx, what we do? we consider the equation a0d square plus a1d plus a2 into y equal to 0 irrespective of Rx. Whatever Rx I have given, I always write here 0 to find ycx. And so, what is my auxiliary equation? My auxiliary equation is a0d square plus a1d plus a2 equal to 0. And so I have two values of d. Say it is m1 and m2. And therefore, my ycx will be of this format: c1 into y1x plus c2 into y2x. This is important in variation of parameters method. Right. Now in the second step, what we do? Now we are proceed to find ypx. And to find ypx, right, first I find Wronskian. This is new term for you. So the W stands for Wronskian. And the Wronskian is defined in this way: the determinant of y1, y2, y1 dash and y2 dash. Right. You need to find out this Wronskian. What is y1 dash? The derivative of y1. What is y2 dash? The derivative of y2. And then in variation of parameter method, the formula for ypx is defined by minus y1 into integration of y2x into rx divided by Wronskian plus y2 integration y1x rx divided by w dx. And therefore, the general solution yx is equal to ycx plus ycx. So, what is on the screen is the perfect method of the variation of parameters. Again, I repeat, I have given this differential equation. First, I find ycx by considering rx equal to 0. So, I get two functions, y1 and y2. Then I find out Wronskian. This is important. There must not be any mistake to evaluate this Wronskian. Then I apply this formula. And this is not difficult to memorize. But see, here in the denominator we have w. So what happens if w is 0? But here y1 and y2 are always linearly independent. And therefore w is always non-zero. So there is never be issue that w is 0. Right. Let us discuss the exercise with this particular example. Okay. But one question arises. We are already having these three cases: Rx equal to this, or Rx equal to this, or Rx equal to this, and we have this method or this method. Right. For all the cases. Then why do we need variation of parameters method? So this particular example, is enough to understand, right? If the example is enough to give the answer. Let us start with this exercise. Solve y double dash plus y is equal to sec x. Now see, for this particular example, this Rx right hand side is not exponential. This is not either sin x or cos x, and this is not any kind of polynomial. That simply means any one of these cases is not applicable, right? And so variation of parameters method is useful because this is useful only this particular cases: exponential, trigonometric, cos or sine, or polynomial. If you have given this kind of function sec x or log x, right? For example, if I write another example, then say this is exercise number 1. Exercise number 2 is d square plus 2d plus 1 into y is equal to e raised to minus x into log x. Say, right. So again, here we have given log x. So our last method will not be applicable. So let us start the solution. Okay, solution of this exercise, what we have given, y dash plus y is equal to sec x. So the question arises, how do you represent in the examination? What I have given, y double dash plus y is equal to sec x, and I rewrite this as d square y plus y equal to sec x, and solve d square plus 1 into y equal to sec x. Right. This is our equation number 1. Now what we do in case 1, we write to find ycx. What we do? We consider right hand side as 0. Right. So in place of this bracket, I always write 0. There is no change in the left hand side, keep in mind. Clear? And so d square plus 1 equal to 0. And which are the factors? D plus I, D minus I equal to 0. And for D is equal to plus or minus I. And therefore ycx is equal to, now see which case is applicable here. This plus or minus I is nothing but alpha plus or minus I beta, and therefore alpha is equal to 0 and beta is equal to 1. Right. So I am writing here alpha is equal to 0, beta is equal to 1, and so ycx is e raised to alpha x into c1 cos beta x plus c2 sin beta x. Right. Here alpha is equal to 0. So this is e raised to 0x c1 cos beta is 1 plus c2 beta is again 1. So c2 sin x. And so what is our ycx? E raised to 0 is 1. right? So this is C1 cos x plus C2 sin, where C1, C2 belongs to R. This is our YCA. Very much important, right? Now see, if you look at variation of parameters, then in YCA we are writing C1Y1 plus C2Y2, and those Y1 and Y2 we are using in the Wronskian, right? So let us compare this with C1 Y1x plus C2 Y2x. This is simple comparison, right? So what is Y1x? Y1x is equal to cos x, and Y2x is equal to sin x. Clear? And therefore, what is Wronskian? How do we define Wronskian? Y1, Y2, derivative of Y1 I am writing here, derivative of Y1 and derivative of Y2. So let us write, what is Y1? It's cos x, Y2 is sin x, Y1 dash. So derivative of this cos x is minus sin x. Derivative of this sin x, that is cos x. And so this is equal to cos square x plus sin square x. How it is cos square x plus sin square x? The determinant cos x into cos x, cos square x, minus sin, minus into sin x into sin. So minus minus plus sin square x, and therefore it becomes 1. Right. So what is Wronskian here? W is equal to 1. As we discussed earlier, Wronskian is always non-zero. Right. Now, what is the formula for YCA? And here you need to be careful. So how do I memorize this formula? I always write minus y1 plus y2. Right. As I already have y1 here, y2 here. So same thing I am writing here. This is y1 with additional minus 1, and here y2. Clear? Now I write integration. This is y1, y2 is remaining. This is y2, y1 is remaining. Right hand side, and divide by Wronskian, dx dx. That's it. Clear? So let me write in this way: y2 into right hand side divide by Wronskian, y1 right hand side divide by Wronskian. Now let us substitute all these values minus y1. What is y1? Y1 is cos x. So let me write cos x integration. What is y2? Is sin x. So sin x into right hand side rx. What is rx? That is right hand side sec x. That I write here, sec x divide by Wronskian is 1. That you know, Wronskian is 1. Right. Dx plus y2. Now you know y2 is sin x. So let me be little bit fast. Y1 is cos x, rx is sec x, divide by 1 dx. Clear? So this is equal to minus cos x integration. This is what? Sin x. And what is this sec x? Is 1 upon cos x. So this is sin x upon cos x dx plus sin x integration. Can you tell me what is this quantity cos x into sec x? Is it 1? Okay. So this is 1 into dx. So this is minus cos x. Okay. What is this? Sin x upon cos x is nothing but tan x. And what is the integration of tan x? Bravely, should I write ln mod sin x? So I am writing ln sin x, right? Plus sin x as it is. What is integration of 1 with respect to x? It is x. So let me write x into sin x. This is our ypx, particular integral. Isn't it easy? Keep in mind, in particular integral, there does not exist any arbitrary constant. So I never write plus c. Particular integral never contains any arbitrary constant. All the arbitrary constants will be always in ycx. Keep in mind, right? And how do you end this exercise? Therefore, the general solution is yx is equal to ycx plus ypx. Therefore, yx is equal to, what is ycx? This is c1 cos x plus c2 sin x. c1 cos x plus c2 sin x plus ypx. What is ypx? Minus cos x ln sin x plus x sin x. So now I am writing x sin x here and minus cos x into ln sin x, where c1, c2 are real. This is the end of exercise. In the examination, you are always supposed to solve the exercise in this manner. Again, I repeat, this is the first exercise. What we are doing, we have given this differential equation. We write in terms of d. To find ycx, we consider right hand side as 0. We factorize this. So we have d. We check which case is applicable. So we write ycx. In ycx, except constant, the other two quantities are my y1 and y2. Right. Next, using y1 and y2, I find the Wronskian. This is the Wronskian here. Then I mention the formula. I substitute the values, right? And then I integrate. And finally, the last step is, what is the general solution? Should we discuss another example? We have this another exercise. D square plus 2d plus 1 into y equal to e raised to minus x log x. So let us write the exercise. Second one, d square plus 2d plus 1 into y is equal to e raised to minus x log x. Right. Let us write the solution. What we have given? D square plus 2d plus 1 into y is equal to e raised to minus x into log x. This is equation number 1. right? To find YCX, what I do? I consider the right hand side as 0. So I have d square plus 2d plus 1 into y equal to 0. And therefore my auxiliary equation is d square plus 2d plus 1 equal to 0. And which are the factors? This is nothing but d plus 1 whole square equal to 0, right? And therefore, what is d? Minus 1. Will you write in this way? No. There are two factors. D plus 1 whole square is what? D plus 1, again d plus 1, right? So this gives me minus 1. This again gives me minus 1. Keep in mind, whenever we have second order differential equation, it always having two roots, right? And so, what is YCX? This is equal to C1 e raised to minus x plus C2 e raised to minus x. Will you write in this way? Yes, because it has two roots, M1, M2, both are real, right? And equal also. So how do we write? C1 e raised to M1x, C2 e raised to M2x. But M1 is equal to M2, so I write M1 here again, right? These two functions must be linearly independent, and so I multiply by x here. Clear? So I multiply by x, where C1, C2 belongs to R. Suppose this is the exercise of 7 marks in the examination, then for YCX you will get 3 marks. Right. Now for variation of parameters, what do we need? We need y1 and y2. So I compare this with c1 y1x plus c2 y2x. And therefore, what is my y1? E raised to minus x. What is my y2? Is x e raised to minus x. Right. Once we have y1 and y2, we are able to find the Wronskian. Now, Wronskian is equal to, what is Wronskian? First row is y1, y2. Second row is derivative of both the functions. Right. So, what is y1? E raised to minus x. What is y2? X e raised to minus x. What is y1 dash? Derivative of this. So I write derivative of e raised to minus x is e raised to minus x. By chain rule, derivative of minus x is minus 1 that I write here. So finally it is minus e raised to minus x. What is the derivative of x e raised to minus x? X as it is. Then derivative of e raised to minus x is clear, plus. Now e raised to minus x as it is, then derivative of x is 1. So it is minus x e raised to minus x plus e raised to minus x. Once you solve this determinant, this multiply by this, so minus x e raised to minus x into e raised to minus x. This one. Can I write this is e raised to minus 2x direct? So I am writing it as e raised to minus 2x plus e raised to minus x into e raised to minus x is e raised to minus 2x. Minus sign, and again I write something. Minus sign, then multiplication of these two. 1 minus sign I already have. Right. So it is minus x e raised to minus 2x. So this is equal to minus x e raised to minus 2x plus e raised to minus 2x minus minus plus x e raised to minus 2x. And so these two will be cancelled out, and therefore Wronskian is equal to e raised to minus 2x. If possible, always write in the examination that this is non-zero because this is any function, right? This is the function e raised to minus 2x I mean, and which is non-zero function. Now we are ready to find ypx. So what is ypx now? Minus y1 plus y2 integration y2 into rx divided by Wronskian dx. Here it is y1 into rx divided by Wronskian dx. So this is equal to minus, what is y1? E raised to minus x. y2 is x e raised to minus x. Right. So let us write y1, which is e raised to minus x, integration. What is y2? X e raised to minus x. Okay, what is r? Right hand side. Yes, look at right hand side is this e raised to minus x log x. So let us write here e raised to minus x log x divided by Wronskian is e raised to minus 2x dx plus y2 x e raised to minus x, y1 is e raised to minus x, rx is e raised to minus x log x divided by Wronskian e raised to minus 2x dx. Now can I cancel out e raised to minus 2x and e raised to minus 2x? Yes, we can cancel out. So this is minus e raised to minus x integration x log x dx plus x e raised to minus x integration log x dx. Okay, now can you tell me what is the integration of x log x and what is integration of log x? So let me explain integration of log x. This is nothing but integration 1 into log x dx. This is my u, this is my v. Clear? So by integration by parts, right? How do you write? Yes, I know. You know what is the integration by parts, right? Integration of uv is equal to u integration of v minus derivative of u integration of v, all integration. But integration of v, so here integration of log x we don't know, right? So I don't assume this as u and this as v. Clear? So it's always try and error method you need to apply. So suppose this is my u, this is my v. So this is equal to u integration of v, that is integration of 1 is x minus derivative of u, right? Derivative of u, that is derivative of log x is 1 upon x integration of p as dx. So here x and x will be cancelled out, so only 1 is remaining. Therefore this is x log x minus integration of 1 is x. So if I take x common, then this is log x minus 1, right? So this part is clear. Plus x e raised to minus x into x log x minus 1, right? Now the question is, how do you solve this integration? Integration of x log x dx. So let us try. Again we are saying this is my u and this is our v, right? So this is equal to u as it is integration of v. What is integration of x? X square by 2 minus derivative of u, that is derivative of log x, integration of v, x square by 2 and whole integration. So this is equal to x square log x by 2 minus 1x will be cancelled out, right? So it is integration of x upon 2 dx. So this is x square log x by 2 minus 1 upon 2. What is integration of x? Again x square by 2, right? And therefore this integration is minus e raised to minus x square log x by 2 minus x square divided by 4. Clear? And therefore ypx is equal to minus, let me write in this way. First I write polynomial, so x square e raised to minus x log x divided by 2, then minus minus plus x square e raised to minus x divided by 4 plus, now we are here, right? So actually this is x into x square e raised to minus x log x square e raised to minus x log x. Then this minus sign x into 1, right? I repeat, minus sign x into 1 into x into e raised to minus x. So that is minus x square e raised to minus x. And so this is equal to, now let us see, these two terms will give us x square e raised to minus x log x divided by 2, right? Then these two terms, right? So it is actually 1 upon 4 minus 1, which is minus 3 upon 4, right? So minus 3 upon 4 x square e raised to minus x. This is our ypx. So sometimes it takes time to integrate the quantity, right? And how do we end the exercise? Therefore, the general solution is yx is equal to ycx plus ypx, and therefore yx is equal to, what is ycx? Look at here, ycx c1 is raised to minus x, c2x is raised to minus x. So that I write here, c1 is raised to minus x plus c2 x is raised to minus x plus, what is ypx? This x square e raised to minus x log x divided by 2 minus 3 upon 4 x square e raised to minus x, where c1, c2 are real. Clear? This is the final answer, and this is how do you write this example in the examination. I repeat, let me explain again because the example is little bit tricky in the last part. We have given this differential equation. We consider right hand side 0 to find ycx. We factorize this, so we have the factor and the root. Then I write what is ycx. From ycx I find what is my y1, what is my y2, right? From y1 and y2 I find Wronskian. I never make any mistake in the derivative as well as in the simplification of the determinant. This is minus sign. Be careful, right? And so we have Wronskian. I always mention Wronskian is not equal to 0. Then I write the formula for yp. I substitute the values of y1, y2, right hand side, Wronskian everywhere, and then I use our usual simple integration trick. How do we integrate a log x? So this is the procedure. If you want, you can mention in the examination, or in rough work also you can do. What is integration of x log x? So this is how we find. You can write the answer, or you can mention the step. And therefore we have ypx finally, right? And therefore the general solution. So this is the variation of parameters method.